Okay, so this chapter 8, is the first chapter for exam 2. So we're going to talk about the atmosphere, how it works, and we're going to introduce some of the concepts today and terms for chapter 8 from your textbook. So we'll start with the first one. Air mass refers to any specific part of the atmosphere. So if you think about when a thunderstorm comes through, that air is moving as a single unit, a mass. The second term that I want you to know is called albedo. Albedo refers to how reflective something is. So if you compare two surfaces, say one is black and the other is white, they reflect light differently. The black surface absorbs radiation more, the white tends to reflect it. And so when we talk about albedo, it's especially important with regards to ice and glaciers, right? Because ice and glaciers are kind of whitish. The ocean, the liquid ocean, tends to be blue or dark blue. Those two different colors play a very important role in determining how they act with radiation. And this is due to albedo. The atmosphere, you can think of it as the air that exists from the surface of Earth to, I forgot how high the atmosphere goes, maybe 10, 20 kilometers, fairly small, right? So the atmosphere is a very thin layer of air that surrounds the Earth. Outside of the atmosphere is space, right? Outer space, no oxygen. Within the atmosphere, we have oxygen, carbon dioxide, nitrogen, and some other smaller gases, but those were the three main ones. Now, within the atmosphere, just like with the ocean, just like with a pot of water, when you boil it, you create movement, right? So remember, the equator heats up, absorbs more radiation than other latitudes, and this creates an area of low pressure. As this goes up, it cools and sinks in areas of high pressure and creates these circulation cells. We'll talk a lot more about those circulation cells in lecture, but they're essentially just areas that are moving in the atmosphere. Climate is a term that refers to, the way I think about it is long-term weather, right? So weather on the order of tens to thousands of years, right? Hundreds of thousands, millions of years. So when we talk about the climate of Earth, we're talking about a very long time period. When we talk about weather, which is right here, I'll go ahead and do weather, is short term, today, tomorrow, yesterday, right? Very short term. Convection current, we touched on this a little bit ago with the atmospheric circulation cell. Convection current is just like that pot of water where you're heating it, and the water, or in this case, the air, is convecting and moving to redistribute heat. Same principle. Coriolis, all I want you to know about Coriolis is that is what the Coriolis effect is named after, right? The Coriolis effect is the apparent deflection to the right, right? We've seen this a couple times already in this class. So the Coriolis effect is because the Earth is moving, and because the equator travels at a faster speed than higher latitudes and lower latitudes. When things leave the Earth, they travel at the speed from where they left, right? So in the Northern Hemisphere, which is what we talk about in this class, things are deflected to the right. In the Southern Hemisphere, they're deflected to the left. Cyclone is essentially a strong storm. So you can think of it like a hurricane, same thing. Cyclones are just hurricanes in the Pacific Ocean, right? Hurricanes are in the Atlantic, cyclones are in the Pacific. It's just a different term. We'll go ahead and do this one too. So hurricanes just a really strong storm. They tend to be very predictable. In South Carolina, they occur from about now, June, until October, right? So essentially all summer is hurricane season. In the Atlantic, they start off of North Africa. They travel across the Atlantic Ocean where they can build up energy and moisture. And then they make landfall typically in the Gulf of Mexico, the east coast of the United States. So hurricanes are just really strong storms, but thankfully they're very predictable. But they do cause large amounts of damage, and unfortunately they displace and destroy a lot of homes and businesses. Doldrums are areas on the earth where you don't have a lot of wind. And so this typically happens in areas, this is a really big term, Intertropical Convergence Zone, ITCZ. All you need to know about the ITCZ is that's where it's really hot and there's a lot of moisture. And so you tend to have a lot of clouds, right? So if you look at a satellite image of the earth, you can see the ITCZ because you have very distinct bands of clouds, right? Now what happens associated with these is you have areas with no wind, right? And these are called doldrums. So if you're sailing a ship and you go into a doldrum, you're going to sit there for a while because there's no wind. Extratropical cyclone. All I want you to know about this is a type of cyclone. Yeah, I wouldn't worry about the details of this one. Ferrel cell is a type of atmospheric circulation cell. So we have Ferrel cell. Another one is Hadley cell. And the only reason I have Hadley cell selected is that's the one kind of that goes right through the middle of the Northern Hemisphere, right? Where University of South Carolina is located, right? So if you kind of look at the middle part of North America, that's the Hadley cell, right? And we also have a polar cell, right? Remember there's 3 cells, Ferrel, Hadley, polar in the Northern, and the same 3, same names in the Southern Hemisphere. Horse latitudes is just another name for doldrums. I don't know why they have them both in here. Hurricanes we talked about, ITZ we talked about. Land breeze refers to a breeze over land. It's really just if you go outside of your house or your apartment or school and it's kind of breezy, it's a land breeze. There's not a lot of water on land usually compared to the ocean. So land breezes tend to be very, not have a lot of moisture in them. Meteorological equator. This is a term that refers to as the earth rotates, things shift. So for example, we talked about monsoons and how monsoons kind of shift. They do this because of the ITCZ. The ITCZ also moves as well. So when we talk about the equator, typically what we do is we draw a line and call it 0 degree latitude. And that's fine. But in terms of meteorology, that equator can change, right? And it changes with the seasons, the rotation of the earth, etc. Monsoon, we talked about it a little bit in class. It's essentially a shift in the ITCZ in the Indian Ocean, and the winds change direction. Instead of coming from land to the ocean, they go from the ocean to the land. And when this happens, they bring a lot of water to land, right? So the monsoon season is a period, especially in India, where there's a lot of rain. A nor'easter or northeaster is a term for a storm in the Northeast United States, typically. And remember, winds are named from where they come. So a nor'easter is wind originating in the Northeast and going to the Southwest, right? And so nor'easters tend to be very powerful, especially around New York and Maine and Massachusetts, because when it's coming from the Northeast, that means it's coming from the Atlantic Ocean. Just like monsoons, they carry a lot of water. So you can get, if it's a nor'easter in the winter, you get a lot of snow and ice. If it's a nor'easter in the summer, tend to get a lot of rain. Polar cell, we've already talked about a little bit. It's the most northern atmospheric circulation cell. Polar front, not terribly important, but every now and then you'll hear about it, especially in the United States, where you have in winter, you'll have an unusually cold week, right? And this has been happening the last couple of years. And you'll have the polar front, which is a meeting between different air masses. And for some reason, climate change primarily, we'll talk about this later, in addition to other things, the front will dip down and come further south. And so you'll have these super cold, frigid northern temperatures come down further than they normally do. And this can be really bad, you know, because people aren't used to that type of weather. And so it can create a lot of trouble and, you know, loss of life and food and crops and transportation. So polar fronts are something that's becoming more and more common. Precipitation, just another way to describe things that come out of the atmosphere, like rain and snow, moisture, precipitate, right? That's all it is. Sea breeze, the opposite of land breeze, is coming from the sea. Typically, they tend to be cooler, they contain more water. Storm, very general term, but usually a storm is a disturbance in the atmosphere. And this could be a variety of different things. It could be a thunderstorm, it could be a hurricane as an example, it could be a cyclone. There's lots of examples of storms. Now, this next term that I want you to know is called storm surge. Storm surges are pretty much found with cyclones and hurricanes. What happens is as you have the hurricane moving or the cyclone moving, it has low pressure in the middle and that air is going up very quickly. And as it goes up, it's an area of low pressure. So the water in that center of the storm, instead of being flat, that water is kind of pulled up, right? So you can think that low pressure is kind of lifting up the water. And that's called a storm surge. This is really bad because some storm surges can be 3, 4, 5, 6 meters. So when those storms come to land, instead of the water being here, it's actually up here, right? And that's the storm surge. So it's essentially a wall of water. And when we talk about hurricanes, storm surges are probably the most damaging part. I mean, the winds are bad too, but the storm surge is just as damaging, in my opinion. Thermal equilibrium, excuse me. It's where the temperature of something is in equilibrium. So if you think about like, say I have a cup of coffee and I heat it up, it's hot, and my office is cooler, right? That is not thermal equilibrium. If I let my coffee sit for a couple hours, my coffee will get cold, right? And it'll be the same temperature as my office, right? That's thermal equilibrium. Next one's tornado. Tornado is essentially, the way I think about it, it's not really a hurricane on land. It's essentially a disturbance in the atmosphere that has very strong winds going opposite directions. And when this happens, you can create very strong convection cells on land. And that's a tornado. And tornadoes are very unpredictable. A lot of people compare them to hurricanes, but hurricanes are very predictable. You know where they're going to be 2 or 3 days before they're there. Tornadoes can pop up like that really quickly. Trade winds. Trade winds are winds that occur at kind of mid-latitudes on the ocean. They're called trade winds because a lot of sailing vessels would use them in traveling, because if you get into trade winds, you go much faster than if you weren't. So if you're trying to sell commerce or go to a different continent and you're in a sailboat, trade winds are where you want to be. Tropical cyclone, we already talked about. It's essentially a hurricane in the Pacific. Water vapor is the water in the air. It's the gas form of water. It could be steam. Weather describes what surrounds us in terms of the atmosphere, right? So today is hot and dry in South Carolina. That's the weather. Tomorrow is probably going to be hot and rainy. right? So it's kind of, again, weather is kind of short-term climate. Westerlies, we've touched on this a little bit already. Westerlies are winds in our latitude, in where the central part of North America, where University of South Carolina is. It's in the Hadley cell. So the winds, again, named for where they come from, the westerlies travel, and they give us a very predictable weather pattern. And then the last one is wind, and wind is just movement of air, typically caused by atmospheric circulation. So that is it for chapter 8. So I hope that helped you all out, and let me know if you got any questions.